All right. Welcome to the wonderful world of IPv6. Yes, IPv6 is a part of this new CCNA as well. You're never going to get rid of IPv6 unless we go to IPv7, which I don't see it happening in our lifetime. All right. So let's go over the basics, right? Things you probably already should know or you're about to know. IPv6 is a 120-bit address. We know this. All right. It's in hexadecimal format. You have 240 undecillion addresses. We cannot fathom that. I can't fathom that. The only analogy that I have for you is just, I don't know where I read that, where it says that if you take a grain of sand and you fill up a truck, a dump truck, that will be IP version 4. If you take a grain of sand and fill up the sun, that would be IPv6. So think about that. All right. So you have more than enough addresses, and within that's the complete total of addresses. What you have per subnet is 15 quintillion addresses. For you math geniuses out there, you can go ahead and look it up. It's there. All right. But that's you don't have to worry about that site anymore. All right. Good things is that we have no broadcast. There is no broadcast. There is no ARP anymore. All right, it's been replaced. So we have no more ARP. Cool. All right, no broadcast at all. All right, so, and of course it brings new features. So what are those new features? Well, we got a new type of addresses. Yeah, we got anycast address, the 1 to nearest. Okay, meaning this address, which comes from the range of linked local addresses or unique linked local addresses, it comes from there. And what happens is that address can be in multiple places. Let's say you have servers and you have multiple servers with the same address. You're looking for a particular service, okay? So you look for that address, right? Your routers, obviously, because it's always based on the metrics of your routing protocol, what it's going to configure. Okay, who's nearest to me that holds this particular service and is going to go there first? Okay, so you can have, let's say looking for a service in a particular router. Since we're talking about routing. All right, you have 8 routers that have the same address, but you're looking for the nearest router to you. But that's all based on your routing protocol, right? That's why they say is 1 to nearest address. Okay, so we have the anycast, the linked local address. That's new. That's the FE80. All right, that exists on every interface. Okay, it exists on every interface automatically. It's like the replacement of a PIPA. All right, that's always going to be there. So it's going to be there, and it does a lot more things than what the APIVA used to do. Okay, global unicast address; those are our public addresses. All right, we have transition mechanisms such as dual stack, 64 tunneling, and NAT64. We'll be seeing a dual stack lab in here as well. We have the EUI64 auto configuration. What is that? Well, instead of putting an IP address, we just put the network prefix of the address with the prefix length, which is that slash whatever, but there's no slash anymore, okay? The prefix length, and then you go EUI64, and what it does, it takes that 48-bit address or MAC address of that interface and pads it, like it says right there, pads it with a triple FE smack in the middle of the MAC address to turn it into a 64-bit address, giving you the interface ID portion of the address, meaning the host portion, if you want to call it that, of the address. So brand new stuff, EUI64, very nice, very nice. All right, smaller header is a 64-bit, 120-bit address actually. All right, but the header is twice as small as the IPv4 because they got rid of it. Well, you can always put it back in if you want to, but by default, it's a very small header, okay, which makes it more streamlined. ICMP version 6, boy, this guy's got a job and a half. Why? Because it looks for router solicitations, router advertisements, neighbor solicitations, neighbor advertising, dad. Who's dad? Duplicate address detection. ICMP version 6 is responsible for all that stuff. He's make sure that, hey, is there, when you ping somebody, dad goes out there with you and finds out, hey, is there an IP address out there the same? Is everybody unique? Yeah, we're all unique, dad. So dad comes back and says, okay, everything's good to go. All right. So Duplicate address detection. If you have 15 quintillion addresses, I don't think you should have an issue. But regardless. But this also, just to give you a heads up, not in the exam, but because of router solicitations and router advertisements and all that, very difficult to work with IPv6 in the network and creating access lists and working with certain third-party applications because they still don't have support, meaning it's wide open. Now with this BYOD, bring your own device, okay, it's wide open. You can't block ICMPv6. If you block ICMPv6, you literally just bring down your network. So you need to find a way around that, okay? Not in the class, not in the course, but just to give you a heads up for out there in the real world, okay? So think about what you're going to do because I know there's a third-party application out there that, you know, it maintains and monitors and assigns and does everything for you, but with IPv6, yeah, not yet, okay? Not yet. But anyway, just know that this is what it does, and do not do it in a practice lab first before you put it in production. You know, what is it you're going to do to secure your IPv6 network? All right, here's a breakdown of the IPv6. The first number here, starting from left to right, this is your registry, right? 2001, the registrar, Aaron, whoever, all right? They're the ones that give you this, all right? 2001. Then your ISP gives you this particular number, 3200. And hey, well, the company, guess who this is, right? Facebook, or if you want to, you know, whatever you want to call your company, this is a company address, all right? So we're under this ISP, and the registrar is giving us this public address. So we're going to be using all that. This portion of it is where you're going to subnet. This entire thing is your network prefix. And each one of these sections or fields, whatever you want to call it, is 16 bits long, which gives us our 64-bit portion of the network prefix. Now on this side, we have our host ID or your interface ID. All right. This is where, you know, you can make whatever combination of numbers you want, really, if you wanted to, or we can use that EUI64, whatever what you want to do. Each one is also 16 bits long, okay, making it a 64-bit interface ID, giving us that 128-bit address. And this is no longer called a CIDR or a subnet mask or a slash anything. This is your prefix length. All right, same thing. If you were to turn all this into binary, that means 64 bits out of the 128 bits are on. All right, so that is the default line that you see here. That's where the break is right here between the network prefix and the interface ID or host ID, okay? That normally people use because they're not that familiar with IPv6. They're not comfortable subnetting in IPv6. So you can always say, if you don't know what the heck you're doing, just put a 64, you're good to go. All right? All right, so that's how this is broken down. And this is an example. Now, this is for short expression, but this is how you see it here. 2001, 3200, bad. 2000, and then 0015. Then you got the 0 ABC, 000, 001, and then 64, right? Well, there's a way, I mean, because writing all this, and, you know, Notepad is your friend for this because you're going to be copying and pasting left and right. All right? But there's a way where you can get rid of, it's called the rules of leading zeros. The rule of leading zeros. Any zeros in front of a number, you can omit. Any zeros in front of the numbers, you can omit. So as you see the numbers that have turned into red, this address will look like this. You take out the zeros from the 15, take out the 0 from the ABC, and you take out all the zeros, consecutive zeros over here, and you'll truncate it to one double colon. And there's another rule that's called you can only have one double colon in the entire address. You cannot have two double colons. You cannot have two double colons. You can't do that. Because if you would have had to say consecutive zeros over here, you would have to then put a 0 here and then have that double colon, or vice versa, have the 0 here and the double colon over here. But you cannot have two double colons. That will be an invalid and illegal IPv6 address. You're not going to jail or nothing, but you can do it. All right. And here's another example of the same thing, but look at that. All these zeros and 12. You can go ahead. I put in 0 so you can see that I just put 1 0 1 0 1 0. Okay, and I took out the zeros from the 12, but I could have easily just put one double colon right there because they're consecutive zeros. All right, and I could have put a double colon and then the 12, it would have been even shorter. So this is the rule. So this is a very legitimate question that I myself used to put on test. Okay, that just, hey, identify a valid IPv6 address. Something simple. All you gotta know is one double colon, and you can take out the leading zeros, the zeros in front of the number. Like, see, can't take out those zeros here, can't take out those zeros, but I can take out the zeros in front. Okay. All right, that's what they consider short expressions. Now, the types of addresses are linked local. The NeoPIPA, it exists on all interfaces. Now, zone IDs, what does it mean by zone IDs? If you have a multi-home computer, let's say, and using IPv6 on your PCs, your servers, what have you, it'll use at the end of the address an actual number, a percent and a number. That's called a zone ID. So when you're pinging, it'll know which way it needs to go, which NIC card it needs to travel through. It'll use that zone ID as an identifier to go where it needs to go. All right. And here are your unique local addresses. All right. They're the same thing as private IP addresses. And this is where they acquire the Anycast addresses as well. All right. And you see here, 1 to near is used the range of unique local right here. And this will be an example. IPv6 address, 2002, Saturday 128, Anycast. By putting Anycast, you're saying, oh, this is an Anycast address. Okay. Then you have the double colon. That's the same thing as using all zeros for IPv4. Here's your loopback address that exists on every single interface. It still does the same thing, but that's just the IP version 6 of it. Here's using a mixture of IPv6, right, 2 double colons, and an IPv4 address. So IPv6 with IPv4. This is the range for global unicast addresses. So that's why you see that normally I use 2001 or you can use 2002. All right, so whatever that is, you can go ahead and put. You can always figure it out if you put it in binary. And then this one here is used for transition mechanism 64 tunneling. All right, if you're going across on the internet, going from router to router to router, and you want to go, 64, you can do it with these type of addresses. All right. So these are the new addresses. Again, you can memorize. These are the main ones they ask you about normally. Oh, and I skipped over the multicast. Multicast addresses you need to know, especially this right here, where I have, again, this will be available to you, where I have the FF029, that's for RIP. That's the multicast address for RIP. FF0210, that's incorrect. It should be A. That 10 should be A, because in hex, 10 is A. All right, and then FF02, 5, and 6 for OSPF. Those are the kind of questionings I think they're more geared to that you would see. All right, like the link local and mixed environment and Anycast. But anything you see with FF, that's a multicast address. FF. If it starts with FF, it's a multicast address. Period. All right. Now, when we start routing with IPv6, before we get into this, when you start routing with IPv6, number one, even assigning an IP address to an interface. If you know you're going to start doing IPv6, the first thing you want to type when you get to global configuration is IPv6 unicast routing. IPv6 unicast routing. All right, you need to put that in there. You need to put it in there. Is there a hyphen between unicast routing? Yes. Okay. IPv6 unicast hyphen routing. You can tab it. You can question mark it. Look at it. The command is there. IPv6 question mark. And then you'll see what it says, okay? But you need to turn that on in order for you to do, especially routing in IPv6, plus other features for your protocols and even in the interface, okay? But now they really have made it easier for us to go ahead and route in IPv6. Now, this is deadly, right? Static routing, it was bad enough in IPv4, but now we go IPv6 route, the destination and network, actually that will be the network that you would put here with the prefix, the network with the prefix, and then the interface you want to go out by, all right? So you put IPv6 route, the network prefix with the prefix length and the interface that you want to go out by, Okay, that's how you would do it. But we're gonna be doing a lab on all this, so it's no big deal. RIP-NG, all you gotta do is go into each interface of the router that you want to participate in the RIP routing process and just IPv6 RIP. Now this number is a process ID number, all right, to keep track of a local database. All right, so you go IPv6 RIP1, enable, done. You're done. You don't have to worry about advertising networks, no auto summary, class full, class less, none of that stuff exists anymore, okay? So all you gotta do is just enable the routing protocol in the interface. For EIGRP, it's a little bit different. It's a little bit different. You do go to global configuration, you put in IPv6 router EIGRP 100, okay? You gotta turn the protocol on. You gotta turn the protocol on, and then within router configuration mode, there's another EIGRP command which you need to put in a router ID in the IP version 4 format. You have to do that. And then you go to the interface and you go IPv6 EIGRP 100. That's it. This protocol is a little bit whatever, but it's not bad. Or you're still doing the same thing you would always do. IPv6 router EIGRP and the autonomous system. Turn on the protocol by saying no shut, and then within there you do EIGRP router ID and just give it like you would a loopback address 1.1.1.1, 2.2.2.2, whatever it is, and then go into each interface that you want EIGRP enabled and do IPv6 EIGRP and the autonomous system. Done deal. Again, there's a lab for this, so it'll be okay. All right, now OSPF, pretty much same thing. IPv6 router OSPF 1. You got to put in a router ID, because once you put in the 1, it's going to give you a little message. Hey, you can start the process without giving it a router ID. So you go ahead and give it a router ID. You're good to go. Then you go into the interface, and this is where you go IPv6 OSPF 1 area, and whatever area, I put area 51 here just to be funny. But obviously, you know that in the real world, what you want to do is area 0 for the very first time. Area 0. Okay, area 0. That's your backbone area. Now, remember, you must type this first when routing in IPv6. Like I said, IPv6 unicast hyphen routing. All right. And the above will allow routing in IPv6. Right. This command will allow you to route in IPv6. And finally here, we're going to round off the chapter with subnetting in IPv6. Okay. You'll learn how to subnet. You know, this is the fourth section. I told you already. This is how we're going to subnet in the fourth section. And then we will break it down in binary. I use positions. This is my little method, okay, of using positions. And again, there's a lab that we're going to go over there. And then remember, these numbers are in hex. That's one of the hardest things for us to remember, that these are hex numbers. Because we see this, we think it's 1,000. No, it's not. It's 1000. Each one of these values is 4 bits long. 4 times 4, that's 16 bits. That's what makes this section 16 bits. Okay, remember, you're still working in hex. And what I mean by positions is right here. So you got that 1000. There it is right there. You see I broke it down into binary. Position 1, position 2, position 3, position 4. Why is that so important? Because once you draw your line, like we normally have been doing, the bit value to the left, that's how you increment. All right, that's increment. So we got a lot of things that we're going to do, all right, in IPv6. Not only in this particular section that deals strictly with IPv6, but later on in the course when we do other protocols or other types of labs that deal with IPv6, so you can see what happens. Okay? I'll see you in the next.